Hello and welcome to Configuring High Availability Cluster. In this lecture, we will discuss the purpose of configuring high availability cluster and how to configure it. So let's get started. In the previous Kubernetes architecture lecture in this series, we have a setup that consists of one master node and the multiple worker nodes. As you know, each master node consists of four critical components: the API server, etcd, scheduler, and control manager. I'm sure you all know what these components do and their purpose. You can check the respective lecture in case if you want to know more about it. Speaking of high availability of application, it depends on two things. One from the master node side, another from worker node side. In the current setup that you see here, we deploy an application using deployment controller. And we mention the desired number of pod replicas that we want in the deployment YAML file, and then we deploy that. After that, it is the deployment controller's responsibility to make sure desired number of pod replicas are always up and running. In case if one of the pod dies for some reason, then the deployment controller recreates it on a healthy worker node in this cluster. So if one of the worker node dies or fails for some reason, then pods running on that node will be automatically gets recreated on other healthy worker node. So far, this looks great, and this is one side of the coin. So the big question is, if there is only one control plane, if any of the component fails or any of the node fails, then what's next? So besides having a multiple worker nodes and deployment controllers, it is equally important to have more than one control plane node. Ideally, there should be 3 or 5 control plane nodes that should be good enough. In case if you need more, you can increment to the next odd number, which is 7, 9 or even 11. However, in most cases, we see 3 or max 5 control plane nodes in any Kubernetes environment. So if you don't want to keep the overhead of managing these control plane nodes and software upgrades on this, then you can find the various cloud providers providing the Kubernetes services on demand basis. This includes GKE, AKS, and Amazon EKS. And let's briefly discuss about each component when we make this Kubernetes cluster a truly high availability. That is by adding extra control plane nodes. As you can see, in this high availability cluster setup, we have 3 control plane nodes and the multiple worker nodes. As we know, each control plane or the master node has 4 major components. First, speaking of etcd. etcd is a distributed key value database. This is where all the Kubernetes configuration is stored. One of its key features is the ability to run multiple etcd instances. So making it high availability is not a big deal. All you need to do is run it an appropriate number of machines, 3, 5 or 7 as discussed earlier, and making them aware of each other. You do this by including a list of all other instances in every other instance's configuration. For example, when starting an etcd instance, you specify IPs and ports where other etcd instances can be reached. etcd will be replicate data across all its instances. So a failure in one of the node when running the 3 machine cluster will still allow the cluster to accept both read and write operations. Coming to the API server, making the API server highly available is even simpler because API server is stateless. You can run as many API servers as you need. They don't need to be aware of each other at all. Usually, one API server is co-located with every etcd instances. By doing this, an etcd instances don't need any kind of a load balancer in front of them because every API server instance only talks to the local etcd instance. The API servers, on the other hand, do need a front-end load balancer. So the clients such as kubectl, control manager, scheduler, and all kubelets always connect to the only healthy API server instances. That's about the API servers. Now coming to the control manager and the scheduler, making them highly available isn't that simple. Because controllers and the schedulers all actively watch the cluster state and act when it changes, possibly modifying cluster state further. For example, when the desired replica count and a replica set is increased by 1, then the replica set controller creates additional pod. Running multiple instances of each of these components would result in all of them performing same action at the same time. So they would be racing each other, which could cause undesired effect, meaning creating two new pods instead of one as mentioned earlier. So for this reason, when running multiple instances of these components, only one instance can be active at any given point in time. Luckily, this is all taken care by the components themselves. Each individual component will be active when its leader elected. So only leader performs the actual work. So whereas all other instances are standing by and waiting for the current leader to fail. So when it does, the remaining instances elect a new leader, which then takes over the work. So this mechanism ensures that two components are never operating at the same time and doing the same work. So the control manager and the scheduler can run co-located with the API server and etcd, or run on separate machines. When co-located, they can talk to the local API server directly. Otherwise, they connect to the API servers through load balancer. So that's about the high-level overview of configuring high availability Kubernetes cluster. That's all for this lecture. I hope to see you in the next.